So I wanted to give some overall feedback on the refraction investigation that you did on Tuesday. Overall, people did very well. A lot of people commented that it was good to actually interact with the angles and make the measurements, and that helped to kind of bring home the understanding of what was going on with the refraction. That is excellent. Now, I did send out an email to specific people who needed additional clarifications, but what I'm going to go through here in the next couple minutes is just some overall clarifications on questions that several people had. And the first thing was bending toward or away from the normal, exactly what that meant. Well, I've captured two different angles, two different refractions that are taking place here. So if we identify the angles, your angle of incidence on the diagram on the left would be right here from the normal to the surface over to your original light. So if we measure that angle, let's see, we're at 10, 20, 30, 40, 50, 60. Looks like we're right about even on 70 degrees. So theta I is 70 degrees. The refracted ray down here, that angle going from the normal out to the refracted ray, and we're at about 10, 20, 30, 40, looks like we're right about 45 degrees. So theta R would be 45 degrees. So in this case, theta I being 70 degrees, theta R being 45 degrees, your 45 degrees is less. That means that your refracted ray is closer to the normal. And if it's closer to the normal, then that light bent toward the normal. Over here on the second diagram, similarly here, if we measure theta I, let's see, there's 30, there's 40, we're about 45 degrees here. Theta R from the normal over, there's 30, there's 40, there's 50. Theta R is looking to be about 52 degrees. So with a theta I value equal to 45 and a theta R value being equal to 52 degrees, now your theta R value is larger than your theta I value. Okay, so that means that the light had to bend away from the normal. Having a little trouble here. The light bends away from the normal to be able to get that larger angle. So toward the normal, your theta R value is going to be less than theta I. Away from the normal, your theta R value is going to be greater than theta I. Kind of overall then, in summary, in terms of what direction the light bends, substance 1 and substance 2, you can think of the speed, you can think of the index of refraction. If your N2 value is the larger value, that means the light is going to slow down, and when the light slows down, it will bend toward the normal. When your second substance has an index of refraction that is less than the first substance, you're going into a substance of a lower index of refraction. That means that the light speeds up, and when the light speeds up, it will bend away from the normal. Feel free to pause the video if you need to jot down some notes on that. Now, I also wanted to clarify, you made several measurements of different angles. These are the angles that you measured in red for the two different sets of questions that ask you to measure those angles of either incidence or refraction. And then the following question asks you to draw conclusions on what was happening. Well, if we look here, for example, 15 degrees to 11 degrees, 25 degrees to around 18 or 19 degrees, all the way down there, your theta R value is smaller than your theta I value. And so the conclusion then would be that that light bends toward the normal. On your glass to air boundary, if you compare the 5 to 7, the 15 to 24, etc. Now your theta R values are larger than your theta I values, which means that that light will bend away from the normal. Here we have the question, what happens if you change the bottom substance from water to glass so that the light goes from the air into the glass? Well, 74% of you responded that light bends more, causing the angle of refraction to become smaller compared to water. That is correct. Glass has a higher index of refraction than the water did. And when you're going from air into something of a higher index of refraction, that means that the light slows down more. And because it slows down more, it will bend more. On the next question, what happens if you make the top and the bottom substances the same? If the top and the bottom are the same, for example, you have air and air. Well, when light changes substance, it changes speed. And when it changes speed, it bends or refracts. If it doesn't change substances, it's not going to change speed, so it's not going to refract. And that is what 94% of you said, okay, which is correct. Now, if you have additional questions on anything on the refraction investigation, please email me or let me know, but hopefully this has answered any remaining questions. Ponder Physics.